accepted.
Good morning. Morning, class. Welcome to day one of Devoxx. I'm sure you've already had that speech already. This is my, I don't know, sixth, seventh time at this event. It's always an absolute pleasure to come. So thank you for choosing to come and see me this morning as well. I hope you had a great keynote and rest of the conference. So I like this quote. This is from a place called the Santa Fe Institute in New Mexico in the US. And it talks to this idea that cities and human kind of social networks and things are the predominant driving force of change and evolution on the planet. The reason I like this will become clear, I hope, as my talk continues. So, I'm not talking about ChatGPT or Web3 or anything else that's slightly trendy, but I'm going to talk about something that is very kind of a la mode, which is team topologies. So how we structure our teams to best achieve fast flow. I'm also going to be talking a bit about software architecture and how they relate, and also this idea of complexity science or complex adaptive systems, something I've become fascinated in, and which I'll be doing another talk about on Friday afternoon. First of all, to introduce myself, my name is James Lewis. I work for an organization, a software consulting company called ThoughtWorks, of Martin Fowler, chief scientist fame. That's probably most people know us because of him. But we've also been out there, we've done a lot of work in the areas of sort of software engineering, in sort of advancing the craft, so continuous delivery. The book was written by two thought workers at the time, Jez and Dave. Building microservices was written by Sam Newman. Evolutionary architecture, etc., etc., etc. So we're passionate about sharing our understanding, how we build software. And I've been working there for about 17 years, which is quite a long time for any organization these days. But the great thing about working for ThoughtWorks is no year is the same. So it's not like I've been spending 17 years doing one thing. My career, my job title, my everyday experiences have evolved massively over those 17 years. Until now, I have zero clue what I do at all. A lot of it is this, which is apparently marketing. So I started off as a programmer, and now I'm in marketing, which is a very strange thing. I'm probably best known for, back in 2014, with Martin Fowler writing the seminal work, I guess, on microservices, the definition of microservices on his site. And in that paper, we say this: we cannot say there's a formal definition of the microservices architectural style. Instead, what we do is we call out a number of characteristics of microservices that we were seeing in the wild, a number of things that teams were doing that seemed to make them successful. Okay, modulo, all the controversy at the moment about what's a microservice, whether microservices are worth it, etc. Going back to 2014. So those characteristics were these. I won't talk through them. But the rest of this talk really is about what I've been doing since then, and my sort of journey to understand why some of this stuff works. Why, not just the characteristics that we see companies, building software using these characteristics and being successful, but why is it that these things make you successful? In particular, I'm going to talk to a couple of these things because I'm fascinated by this idea of decentralization. So pushing decision-making down to team level, the idea of breaking big things up into smaller bits, running long-lived products based around stable, long-lived teams, and this idea of breaking things up into services and so on. So really this talk is about my quest over the last nearly 10 years to understand why what we do works, why a lot of the stuff we do, continuous delivery, microservices, why Conway's law is a thing, all these sort of things, why this stuff seems to let us build software that's easy to change and scalable and so on. But firstly, I'm going to talk a bit about team topologies. Now, I'm going to ask for a show of hands. I appreciate it's early in the morning, but you can loosen yourself up a bit. Who's read Team Topologies? Okay, who's heard of Team Topologies? Okay, interesting. So for the record, there's not a huge number of people in the audience who are putting their hands up at the moment. So I think Team Topologies is one of the absolute canonical works over the last 10 years for what we do in terms of building software. Might not seem it, on the surface. It hasn't got Kafka in the title. It says nothing about Kubernetes. But what it talks to is how we can go about structuring our teams optimally to deliver fast flow of value. And crucially, whilst limiting the amount of stuff that you have to think about as a developer, right? So minimizing cognitive overhead or cognitive load. And this book was written a couple of years ago now by a couple of fellows in London who are long-term members of the London Continuous Delivery community called Matt Skelton and Manuel Pais. Here's a question, or here's rather a quote. I was at an event and someone said this. They said, the bigger we get, the easier it becomes to get bigger. And they were talking about Amazon, about AWS. They were talking about how at Amazon, in particular AWS, as time goes on, they seem to be able to go faster and faster and faster. Right? They seem to be able to be accelerating the pace at which they can write software. The more teams they create, the faster it is and easier it is to stand up new teams. The more features they add, the easier it is to add new features. Now that's not really, in general, my perception of how big software organizations are able to build software. Things tend to slow down. I'll come to that in a minute. But the bigger we get, the easier it becomes to get bigger. Now, what is it about Team Topologies that is so interesting? So Team Topologies is an attempt to help answer this question. How can we get faster as we get bigger? How can we structure ourselves such that as we add new teams, we can continually, safely and sustainably increase the flow of value to our users? This is my favorite quote, one of my favorite quotes from Daniel Turhus North. The function of good organizational design, the function of good team design is to safely and sustainably reduce the lead time to your customer saying thank you. But what is value? What is it we're trying to deliver as an organization, as a software development organization, as a team? What is it when I'm sitting down day to day writing code? What am I trying to do? I'm trying to deliver value, but what is value? Now, I would argue that value is stuff, right? We are no different to we are in some ways, I'll come to that, but we're no different in a lot of ways to a machine in a factory, right? As a developer, we're taking a thing that's got less value, whether that's a requirement or user story, whatever you call it. We're doing a thing to it, and we're increasing its value, and then we're deploying it into production, right? Where hopefully someone's going to say thank you. That's what machines in factories do. They take raw materials, a thing, but a physical thing in a factory. They do a thing to it, and then they produce another thing which has more value, which is then sold. So, value is generally just stuff. In some cases, it's physical stuff. In our case, it's information, essentially. We are trading in information. We're adding value to information to turn it into working software which has value. If you squint, physical products and knowledge work are pretty much the same thing. And this is kind of interesting because the parallels between how factories work or how software organizations work will become a bit apparent later on. So essentially what we're doing as software development organizations, we're taking ideas, we're taking raw materials, we're turning those ideas through progressive stages of adding value, whether that's analysis, whether that's doing design, whether that's UX, and then finally development and testing, and then putting something into production, and hopefully someone says, thank you. Now the problem with this is in most organizations, big organizations, old organizations, it takes a really long time to progressively add that value. Now this is a value stream map from about 150-year-old organization that I was consulting with a couple of years ago now, and this is how they go from idea at this end of this value stream map through into that green thing right at the end. That's in production. That's until finally. Once upon a time, until finally. And over here they've got enterprise architects and business requirement people and planners and PMOs, and they're doing stuff. They're creating documents, and they're adding value to this information. It's progressively going along and going along and going along. I don't know if this laser is working. Not so much. Ah, maybe. There you go. That little blue card there, that's writing code. All the rest of it is stuff around writing code, right? How long does stuff take? And in most big organizations, this idea of delivering value to our customers until they can say thank you, while they say thank you, takes a really long time, a lot of the time. And really that's what the rest of this talk is about, why that is. Why is it that some of these things like team topologies can help with that? So team topologies, as I say, written a few years ago. What I love about this book is it gives us, much like domain-driven design, the blue book, talks about Erica Evans's blue book. It gives us a ubiquitous language to talk to each other about teams and how we structure software delivery organizations. It sets out a set of patterns for team design, if you like, and a set of, heuristics for how to slice your teams and form them into these different patterns. So I won't go into it too much. I can't recommend this book strongly enough. But these are the 4 fundamental topologies that they talk about in this book. The idea of a stream-aligned team, the idea of being able to have a direct line of sight to your customer, delivering a single value stream, enabling teams who are there to help the rest of the organization go faster, complicated subsystem teams. Now, these are teams that every organization has got a hard thing that not everyone in the organization can do, whether that's quants in an investment bank, whether that's risk adjustment in an insurance firm, whatever it is, there's going to be something that's complicated. Often you need a complicated subsystem team or some set of people who are able to deal with that. And then platform teams, self-service platform teams. And this is where this idea of value streams is extended to the platform team. So a platform team is a part of your organization that is providing self-service tools to allow other people to go faster. In much the same way that an enabling team is providing people or consulting or help to allow your teams to go faster. Maybe that's with InfoSec, maybe that's with other types of security, maybe that's with UX. Scarce resources who are helping the other teams go faster. So is your platform team, except they're doing it by providing self-service access to tooling. Now, I mentioned one thing about this streamlined team, this idea of direct line of sight to the customer. That's super important. And that came from Amazon many years ago, and we'll be returning to that in a bit. I'd briefly like to talk a bit about software architecture as well. So here's this curious case of Amazon. As I said, the bigger Amazon gets, the quote was, the easier it is for us to get bigger, the easier it is for us to go faster. Now, I'm quite lucky. I travel a lot. These folk behind me, so I'm sort of one of the grumpy uncles of microservices. This is another one, Adrian Cockcroft. He was at Netflix. He coined the phrase fine-grained service-oriented architecture. And this is when we were at a workshop in the beautiful island of Anguilla in the Caribbean. Now, it's a tough job, but someone has to go to workshops in the Caribbean, and I'm that person, right? So awesome. Now, this is, on the end, someone else. I don't know if anyone recognizes this fella. Any shout? No? So I mentioned at the start a very famous law that's become very well talked about a lot, Conway's Law. That's Mel Conway. He actually exists. He's a real person in real life. He didn't sort of just disappear after he wrote this paper back in the 60s. And we were at this workshop with Mel Conway. We were talking about the uses to which we put Conway's Law over the years, and how we'd used it to break up our software architectures, how we'd used it to deliver software in a more effective way and to build a more effective organization. One example, Adrian was talking about Netflix, where they sit people who need to talk to each other close to each other. I know that sounds simple, but that's not often the case, right? So the people who are building the front ends for all the different TVs and PlayStations and everything, they sit quite close to the platform API team, because they need to talk to them. They need to ask for changes to the API. But they sit miles away from the Cassandra folk, people looking after their Cassandra rings, because they don't need to talk to them at all. What Adrian is talking about is the idea of maximizing the bandwidth between people who need to talk to one another, and minimizing it between those who don't. Now, Martin Fowler's got a great story about Conway's Law. He says one of his friends was like a software architect on a program way back when, and he said, I've got 6 teams, and they're all across the US, like East Coast, West Coast, Central. He said, I don't know what the software architecture will look like yet, but I know there's going to be 6 components. Right? Because I've got 6 teams geographically separated, therefore I will have to have 6 components, right? Because you want people close to one another working on things that they need to talk to one another a lot about. So, at this event, someone from Amazon said this: the bigger we get, the easier it becomes to get bigger. Now, this is received wisdom, I would argue. Right? Most organizations experience this. Adding manpower to a late software project makes it later. This is a quote from The Mythical Man Month, the late, great Fred Brooks wrote 30 plus years ago now. Now, this is received wisdom, right? Adding manpower to a late software project makes it later. Now, why is that? Well, it's because as we add more people to our teams, as we add more people to our organizations, the increase in overhead of talking to one another, the coordination cost, becomes so great at a certain point that it overtakes the productivity gains you get from adding more people onto your team. And this has been received wisdom for a long, long time. So why is it? What is it that Amazon appear to be doing, AWS in particular appear to be doing, that flies in the face of this quote of this sort of statement from Fred Brooks? Research, really. Now, I was intrigued by this, warning data scientists in the room, this is very much a pseudo-graph, so don't shout at me until afterwards. You can keep the booing now. This is log, and this is plotting AWS's revenue and AWS's employee count over a number of years. This is from the publicly available information I had at the time. Now, the important thing here, this 449 is not really interesting, but it's this figure here, 1.15. The exponent in this equation means that AWS are scaling something called superlinearly, in advance of exponential. As they double the number of people, they're getting more than double the amount of money, the amount of revenue that they're generating. All right. So I was thinking, well, this seems to align with what this person at AWS was saying about, as we go faster, we make more money. As we add more people, it's easier to add more people. As we get bigger, it's easier to get bigger. And actually, the revenue figures seem to play out, seem to sort of reflect that. Andy Jassy actually showed a very similar graph to this at reInvent last year, which with the current revenue in it, and the figures reflect the same thing. They're still making more money than they should. Now, why is that? I mean, we can go back many, many years. Back in 2004, Jeff Bezos wrote the famous memo when he was talking about how we're going to restructure Amazon to face the next 10 years. Things had gotten really slow. They were in kind of monolithic database integration hell. How are we going to restructure ourselves such that we get to go faster? And he used what I like to call sort of forcing functions, if you like. He imposed a set of forcing functions on the organization that made them point from a software architecture perspective in a particular direction. He imposed a set of rules that said, you shall do this, and if you don't, you'll get fired. I mean, you couldn't do that in Europe. I mean, good. But, in the US, apparently that's fine. You can just fire people if they don't, well, if they still integrate via databases or whatever. But these are some of those rules. Teams must communicate via interfaces. So no more communication via like database to database, Fertling, everything must be encapsulated, and all communication must be behind service interfaces. Another forcing function, all interfaces must be externalizable. We must be able to sell the thing that you're building. Right? As an interface, it must be robust, hardened. We must be able to sell this thing to the public or expose it to external people if we need to. And then famously, two-pizza teams. Right? We're going to structure ourselves around a set of team sizes that enable really, really fast communication between ourselves. Now, interestingly, I would argue that this is where AWS itself came from. Way back when, I was actually, bizarrely, the 4th Amazon Web Service trainer in the world back in 2011. Amazon had no interest in running training themselves at the time. They didn't know if AWS was going to work. So we sort of saw an opportunity in ThoughtWorks. We said, hey, maybe we could come and do some training, help some teach people how to use your services. And they went, yeah, cool. So we did that for about 2 years, and it turns out Amazon did want to do their own training after all, so we're not doing that anymore. But that's by the by. But back then, we talked a lot about what was making AWS successful. And if you think about this constraint, this idea of all interfaces must be externalizable, that's what they did with their infrastructure. They made their infrastructure externalizable in the same way that they made the rest of them, their offerings externalizable, if you like, which means they've got a marketplace, which means all these things. And crucially, they made AWS self-service. Not for us, but for them. Because self-service things make you go faster. And I'll talk a lot about that on Friday. But this idea of forcing functions into your organization that guide your software architecture in a particular direction, in this case towards discrete sets of services that communicate via these externalizable interfaces, is really at the heart of what caused their success over the next, in terms of their software anyway, over the next decades or so. So these are what I sort of talk about as forcing functions for flow. Forcing functions for your software architecture that allow you to go faster as an organization, for your teams to go faster. Team isolation, high bandwidth within your team, low bandwidth across teams where you don't need to talk to people, limiting interaction to nearby teams, and then scaling but by this idea of Dunbar's number, scaling by small units, small teams, which is what AWS does. When they want to build a new feature, they spin up a new team that's adjacent to all the other teams, completely decoupled. And you can see that if you've ever used their APIs. If you've ever used AWS's APIs, they're vastly different across their different product range, right? There's no real consistent user experience across AWS's APIs, across the API designs, because they've optimized for other things. They've optimized for fast flow, as opposed to coordination across teams, which would give them this consistency. I'm not saying it's terrible by any means, but it's a conscious decision that was made according to these forcing functions. So team topologies, this idea of having a stream-aligned team, having the idea that every team in AWS or in Amazon has a direct line of sight to a customer, that's a value stream-aligned team. This idea of self-service platforms, and then having these other enabling, supporting teams that helps everyone else in the organization go faster. So all of this is described in much more detail in Team Topologies. Please go out and get it. I don't get a commission. It's just a brilliant, brilliant book. And it gives us this vocabulary, as I say, by which we can talk to one another. Now, I did promise I'd talk to you about the why. Why I think this stuff works. I'm swapping for water and coffee, water, coffee. Mouth gets dry, up with the coffee, drink some water, it's fine. And I think it's because of this idea of complex adaptive systems, complexity science. And what is complexity science? What are complex adaptive systems? Now, they came out of this place called the Santa Fe Institute. This is back in the 60s, 70s, something like that. A bunch of people, smart folk from Los Alamos, were interested in the idea, post-chaos theory actually, of what makes simple things turn into complex things. Murray Gell-Mann, a Nobel Prize-winning physicist, he was fascinated by the idea of how you can go from subatomic particles into humans. What is it about humans that the complexity you get from biological life? Well, how do you get that from the simplicity that you get, the simplistic or the very simple things, the building blocks, quarks, atoms, electrons, protons, etc. In fact, he wrote a book called The Quark and the Jaguar about this, which is, he was hoping it was going to be an answer to a brief, what's it called, Stephen Hawking's bestseller, but it didn't really work for him, bless him. So here's the question. What's similar about mice and elephants? What do mice and elephants have in common? Their brain. They're grey, excellent. They've both got tails, 4 legs, ears, a mouth, nose, all that kind of thing. Yeah, absolutely true, they do. The funny thing is, mice, elephants, and all of us share some common characteristics because we are all complex adaptive systems. Right. So mice and elephants and us, we share approximately the same number of heartbeats in our lifetime. About the same. All mammals have about the same number of heartbeats in their life. All mammals share the same blood pressure. I mean, not share it as in there's some pool of blood somewhere we all use, as in we all have approximately the same blood pressure. So why is it, what is it that flexes if you've got these Kleibert's law, which is about heartbeats, you've got the blood pressure thing. What is it that changes between something that's as small as a mouse and as vast as an elephant or a blue whale? And the thing that changes is metabolic rate, essentially. As mammals scale, as they get bigger, they slow down. Like, literally slow down in the sense of they experience life more slowly, in a sense. But also their metabolic rate slows. So they experience life more slowly. Right. As you double the size of a mammal, in fact, what happens is the metabolic rate exhibits a scaling factor of 75%. Now, that sounds weird. As you double the size of a thing, you don't have to eat twice as much or take in twice as many calories to sustain yourself as you double the size of a thing. And you can see it on these graphs from the great book, where it's reproduced in scale, but it's originally from this journal. As you double the size of a mammal, the metabolic rate slows down. They genuinely experience life more slowly. Their cells slow down. Elephants don't even get cancer, really, because their metabolic rate is so slow that their cells don't have the time in their lifetimes to divide enough to get cancer. They experience life more slowly. Metabolic rates in mammals follow a scaling law with this exponent. Now, the funny thing is, another example of a complex adaptive system is a company, an organization. We work in complex adaptive systems, right, as well as being a complex adaptive system. And organizations display some funny scaling laws as well. So this is from publicly available NASDAQ data. As you double the size of a company, in general, according to vast amounts of information out there, you don't get double the amount of revenue. You get 75% of revenue out. As you double the size of a company, you don't get double the revenue. Revenue scales with the number of employees following this scaling law by, 85%. So as a company doubles in size, it generates 85%. Of the revenue. Now, I'll refer you back to that graph. Amazon is getting 115% of the revenue out as it's doubling in size. Doing something weird. Cities, we live in complex adaptive systems. They're another example of CASs. And as you double the size of a city, you don't have to spend twice as much on infrastructure. You only have to spend about 75% of what you might think. So for things like road length, number of petrol stations, number of restaurants, 85%, you only get about 85%. You only need about 85% of the petrol stations as you double the size of a city to service the same population, or relatively the same population. Now, all of these are examples of sublinear scaling laws. And in the great book Scale with Geoffrey West, he writes this: the quantities that do not change when other parameters of the system change, they play a special role in science. What he really is saying there is, if you look in lots of places and you see the same thing, you see lots of straight lines on graphs, it should probably point you to go and have a look further, to try and understand whether there are some underlying principles that can explain these straight lines: revenue growth, metabolic rates, infrastructure scaling. And it's all down to something called economies of scale. So, this is what our CIOs or COOs or CFOs talk about. We need economies of scale as we grow, right? That's what we need to do. We need to economies of scale. So, to define terms, linear scaling on a log plot, when you get this straight line like this, as you double one quantity, you double the other quantity. But sublinear scaling is when you double one quantity, you don't double the other quantity. And all of these different scaling laws are examples of sublinear scaling laws. Now, I mentioned complex adaptive systems. What are complex adaptive systems? They're defined using these four terms, so four properties. They're self-similar. The cells in my body are self-similar to the cells in a mouse's body. A house in Utrecht is self-similar to a house in Rotterdam, or a person working in one organization is the same as a person working in another organization. They're self-organizing, CASs. There is no orchestrator that tells the cells, to grow into James. There's this sort of self-organizing thing that happens. They display complexity, which is that the whole is greater than the sum of the parts. I like to think of this as, so if you took James, put him in a blender, and got James soup, and then you poured James into a James-shaped, like jelly mold, it wouldn't be James, right? You'd just have James soup in a James-shaped jelly, essentially, right? James is more, I am more than the sum of my parts. And I also display emergent behavior. And these are the 4 characteristics of complex adaptive systems. And the funny thing is, those straight lines, those scaling laws, can be explained by 3 further simple principles mathematically. So the first is networks. Network theory is at the heart of complexity science. Different types of networks influence different behaviors or lead to different outcomes when you have them present. So in this case, I've got a hierarchical space-filling fractal network, invariant terminating units, so humans in companies. I was hoping to get our human resource people to start calling us invariant terminating units. They're not having a bean of it, unfortunately. And then optimization, some way of getting fast or feedback. So for cities and companies, that's market forces. For biological systems, for mammals, that's evolution and over evolutionary time. And as I say, these things are everywhere. We are a complex adaptive system. And all of us can be described in a lot of ways mathematically, bizarrely, or certainly the scaling laws that we exhibit can be described using 3 principles. The crucial thing is, whenever you see a hierarchy, whenever a hierarchy is present in a complex adaptive system, you see scaling with this exponent less than 1. Basically, Walmart and convenience stores are basically the same. Now, this hierarchy is really important. As humans, as mammals, we've got hierarchies within us. Our nervous systems are our circulatory systems. In companies, there are hierarchies of information flow, and hierarchies of things like network traffic and so on. And cities, there are hierarchies of things like water pipes. And all of this infrastructure, if you like, circulatory systems, all of this leads to these hierarchies lead to these scaling laws where you don't get the same out when you double the size of the thing. Why does revenue grow as size increase? Why do metabolic rates slow as size increases? It's because of the hierarchies involved. The deeper the hierarchy, the slower things get. As you double the size and double the size and double the size from a mouse to a whale, what you're doing is adding massive amounts of depth into their circulatory system. And just the depth of that hierarchy, explains the scaling law, mathematically. It leads to these weird laws, like bigger animals are more efficient due to this depth of hierarchy in the circulatory system driven by evolution. But bigger companies also are more efficient. As they develop these deeper hierarchies, they become more efficient based on feedback from market forces. If you like, as you double the size of a company, you don't have to spend double the amount on network cables. Right? You have to spend about 85%, which is why bigger offices are more efficient. Right? But mammals and companies slow down as they age. Now, I showed you a value stream map, this idea of flow of value through into production. Now, a value stream map is essentially a slice through the informational hierarchy of the company in which you work. It shows how these concepts of the ideas that the business folk have for new products, it shows how they flow through into production. It's a slice through that informational hierarchy, right? The value-adding hierarchy. In a sense, it's the same slice through a factory, your value chain. And what you see generally in most organizations, as they get bigger and as they get older, is they start adding more and more process stages into the process of delivering software into production, or delivering anything, actually. So in this example, I've called out a set of queues here. Every time you've got a Jira backlog, essentially what you've got is a queue in your system, right? In this case, we've got lots and lots of queues. Anytime you've got a queue in your system, things slow down. Essentially, queues are a bit like a plaque buildup in the corporate arteries, informational arteries. And we don't like plaque buildups in arteries, do we? Because things tend to go a bit south after you get lots of plaque building up. You get things like heart attacks. The question is, how long does stuff take? As we get bigger, as we get older in these organizations, we add more and more process stages. We add more and more queues. In fact, what we start doing is spending more money on trying to keep the company alive rather than actually doing new stuff. And we add more and more constraints in our ability to do that stuff. Principles of Product Development Flow, which is another brilliant book. If you haven't come across this, this is a fantastic book. I've got the references at the end. This talks about how queues add particular properties into your system. Basically, queues increase lead time, they reduce motivation, they increase risk, etc., etc. And whenever we see these queues building up in these old, big, deep hierarchical information flows, it's like the cholesterol build-up in your arteries. As companies scale, what happens is they tend to add more processes and things slow down. But we also deliberately block our corporate arteries with things like lots of queue states and other things that I'll come to. Essentially, every time you see a hierarchy, every time the hierarchy gets deeper, the value stream gets longer, things slow down. It should be obvious. I've got a phrase I like to use, because most organizations don't spend time doing things like plotting their value streams out, looking at how long things take end to end. It's just, we'll just do our stuff. And I like to say that, we're so busy doing the work that we don't have any time to think about how the work works, right? We don't have time to understand how the flow of stuff proceeds in our organizations. There is some good news here, because obviously this is a bit depressing, because what I'm saying is when you've got hierarchies, things are naturally going to slow down, right? There's nothing you can do, it's just maths. So sorry about that. Revelation. But there is some good news, because I think we can identify when things are getting worse. So the great book, again, Accelerate, based on a set of research from Dora, this from the State of Devoxx reports over the years. They talk to a set of metrics we can use to understand when things are slowing down, from a complexity perspective, from a hierarchical, things are slowing down perspective. Here's a fun fact from that research. Change request boards or architecture review boards are predictors of low organizational performance. And I use that phrase deliberately. Predict low organization. If you have them, it predicts you're going to be a low-performing organization by however you measure yourself, whether that's revenue, whether that's lives saved, or whatever. And if you think about that, that's kind of obvious in a way, because given what I talked about, the flow of information through these value streams, the flow of information through these hierarchies, when you impede that flow, essentially things are going to slow down. You're going to get bad effects happening. When you put hard stops in, like a change request board, we have to stop doing what we're doing and wait for someone else to make a decision. That's the equivalent, if you like, of giving yourself a heart attack, of stopping blood flow in the organization, stopping the information flow. But I think we can use the information, the research from Accelerate to actually understand how we're doing as an organization. Are we getting faster? Are we getting better? Are we getting slower or worse? So we can use mean time to recovery, cycle time, change failure rate, number of deploys, and I think that the other one is availability, they call out these days. But these things, by monitoring these things, we can understand whether we're getting better or worse. In the same way that, if you go to your general practitioner, your family doctor, they can take your heart rate, they can take your blood pressure and your temperature. It'll tell them if something's wrong. It won't tell them what's wrong, but it'll sort of give them an indicator as to whether they need to look further. And these things, these metrics, are similar for our teams and for our organizations. So, identifying the signs of aging. Essentially, 4 key metrics. They're leading indicators of your organizational health, like monitoring heart rate and blood pressure. But it doesn't matter how hard we work to get better at these 4 key metrics. We're always going to be limited by the hierarchy in which we find ourselves. Always. It's just maths. So we can work really, really hard and we can get better and better and better, limited to the limit of the hierarchy. Another thing that we have organizations have in common with animals is that they die. 50% churn rate on the exchanges every 10 years. The half-life of a company on the exchanges is about 10.5 years. Organizations merge, they get acquired, they go bankrupt, become insolvent, etc., etc. Much like as we get older, as mammals get older, same thing happens. About every 100 years or so, don't know when, 70, 3 score years plus 10, right? someone dies. It's like that's our half-life, if you like. And it seems to be because as organizations get older, they lose track of what made them good to start with. They lose track of the thing that made them successful. And that is the kind of whatever the new products they were bringing to market, the innovation they were creating. Instead, they focus more and more on the organization themselves, on keeping the organization running, on keeping the organization healthy. In the same way that that's what happens with us. As we get older, we spend more and more of the calories we take in, on keeping ourselves healthy, on repairing damage to ourselves, essentially, until eventually we can't keep up, and then it's game over. It's the same with organizations. It's a function of them being a complex adaptive system of a particular type. They also add more and more processes and constraints, as I've said. And the hierarchies grow and grow. So if you've got a hierarchy, if you are a hierarchical organization, the good news is you need to spend less on network cables as you get bigger, right? Which is good news, to an extent. But the bad news is things slow down, naturally, because generally what happens is we increase the number of hierarchies, we increase the distance that information has to flow before value is delivered. We spend less and less on research and development and so on. Reduce their metabolic rates, and eventually hierarchical organizations almost inevitably come to a sticky end. But there is good news, tying together the things I've been talking about. There's another type of scaling, returns to scale. So this is when you double one quantity on a log-log graph. You see this line, this red line here. This is where we get more than double out. Right? This is something called superlinear scaling, or returns to scale, as opposed to economies of scale. And cities exhibit both types of scaling law. So for socioeconomic factors, cities get more than double what you might think. So things like innovation, wages, and so on. As you double the size of a city, you get more than double the amount of innovation, more than double the number of professionals, more than double the number of lawyers or software engineers or whatever it is, right? More than doubling wage growth. But you also get more than double the amount of crime, disease, and pollution. Socioeconomic factors exhibit superlinear scaling. And then, as I said already, sublinear scaling for things like road length, petrol stations, and so on. Walking speed, incidentally, this is a thing. MIT did a research project where they looked at mobile phone data. This thing about people walk faster in bigger places, bigger cities. It's true. They looked at mobile phone data. As you increase the size of a city or a town, people do actually walk faster up to the limit of how fast their legs can go, which is quite cool. And the thing is, there's a different type of network that drives this superlinear scaling. It's called a social network, right? It's called basically a small world fractal space-filling network, a particular type of small world network, in fact, but still. And these social networks, like the ones like our Twitter networks, like our Facebook networks, and so on, like the networks of friends and family we have, mathematically these drive superlinear growth as you double the size of a city. And it's related to basically human nature, in essence, right? The way our brains have come to work over many, many, many years, many thousands of years, and how we optimize the relationships between ourselves, our family, our friends, and our acquaintances, and so on. These numbers here are something called Dunbar's numbers. We often think about Dunbar's number. He was a sociologist. I can't remember his first name off the top of my head. But he came up with these numbers some years ago to describe the strength of relationships we have with people. So 5 is our nuclear family. We have super strong relationships. And then up to 500, which is a much wider group of acquaintances and so on. So the 150 group, the 150 number, that's often talked about. In ThoughtWorks, we would often grow our offices by 100 groups of 150. But there are these other numbers as well. And that's what's driving this scaling law in cities. Small world fractal network growth, according to our human connections, drives this scaling law in cities. So small world network growth, it's because we can just add new networks onto the side, essentially. So as cities grow, they get the best of all worlds, right? They gain economies of scale for infrastructure, returns to scale for socioeconomic effects. They pretty much rarely die. Essentially, they get 115% more stuff for 85% of the cost. But 115 is interesting. if you think about the exponent on the Amazon graph. So are there other organizations that take advantage of this? As I said, I think ThoughtWorks has grown via Dunbar's number, right? We've built, and a lot of other smaller consulting companies have done this. We build offices at around 150 to 200 people. It means you know everyone in the office. It means your culture your culture becomes particularly strong within an office. I know about my friends' children and whether they like golf or motor racing or whatever it is. The Spotify model, the Spotify model, I would argue, is a perfect example of trying to use small world networks to grow an organization. Decoupled teams building decoupled services, if you like, decoupled from one another, cohesive amongst themselves, with just enough hierarchy to coordinate across those teams. Small world grown via small world network growth. Valve, the software, the games company, famously, their staff handbook was leaked many years ago. And in that staff handbook, they describe how they want to grow. And in that staff handbook, they've got a small world network graph as their optimum model for growth. And finally, Amazon. And this exponent of 1.15, which is the same exponent you get from returns to scale based on social network growth. Right? As Amazon is scaling, they're doing the same thing that cities are doing. They're getting 85%, spending 85% on infrastructure costs, but getting 115% of the revenue growth. Right? That's why they're eating the world. And it's because of the way they're organized. It's because of these forcing functions, essentially, that were put in place a couple of decades ago now, more or less, right? That drove the organization in a particular direction to build software in a particular way, which has led to this. So as most companies get bigger, it gets harder to get bigger. But as Amazon gets bigger, it's easier for them to get bigger. So coming back to this idea of team topologies, team topologies talks about patterns we can use to structure ourselves according to these idea of smaller networks. That's what these value stream aligned teams and these other teams there to support them are about. They're about creating small world networks within your organization that allow you to basically have just enough coordination across them to point in the right direction, but minimize the amount of bandwidth you need to talk to other teams in the organization. So you've got these four fundamental topologies. I guess I'll sum up now. Now, I appreciate that this is a bit of a meta talk. I've not spoken about K8 or microservices much, or React, or ChatGPT, or whatever it is that I could talk about up here. It's not particularly concrete, if you like. But it's been my journey over 10 years. It's been what I've been thinking about. It's been like, what is it that underpins what we do and how we do it? Why is it successful? Why are some companies more successful than others? Why are some organizational designs more successful than others? Why are some software architectures more successful than others? And this idea of decentralization, pushing decision-making out to the boundaries, out to the individual team members, individual teams, having cross-functional teams equipped with everything that they need to get their job done without having to talk to other people, without having to put work in other people's queues, if you like. Organized around stable things, business capabilities. The idea is you organize around stable parts of your business, cohesive parts of your business that don't change too much. And all of this can be, implemented via the ideas in team topologies, which themselves are based on a bunch of underlying mathematical principles, if you like, around network theory, hierarchies versus social networks. So, to drive the point home, social networks, these effects, they employ super exponential growth, imply. Whenever you have hierarchies, they're going to slow you down. It's just maths. Hierarchies slow things down. And it's really easy as we get bigger in terms of our teams, in terms of our organizations, to just scale via hierarchies. It's also why, incidentally, you see super interesting effects in things like microservice architectures when you have like directed call chains, when you have graphs of calls, like one service calls two, which each call two, which each call two. When you see those hierarchies, things tend to get slower as well. In fact, there's something called the multiplicative effect of scaling, which means that if you have these hierarchies like your availability at the top is the product of the availability of all the others. Again, hierarchical effects. So whenever you see these hierarchies, you can expect to see the effects of things like slowing down and that. But the research points to these ideas of social networks giving us these team shapes for flow, team topologies, and a vocabulary to talk to each other about them. And finally, I think about this idea of forcing functions for flow. The ideas that Jeff Bezos put in so many years ago into Amazon, can we think about those for our own organizations to help our own growth, to direct our own growth without having to tell people what to do all the time? Forcing functions. Now, with 6 seconds left, I'll be around for questions afterwards for the next 3 days. Jeff Bezos actually lives just down the road from the Santa Fe Institute. And the book Scale, which is one of my references, he was one of the people that told Jeffrey West that he should write the book. I mean, the phrase, it's not paranoia if they are actually out to get you. Right? Like Jeff Bezos, he's internalized all this stuff many years ago, right? He knows the effects of these networks and how they can drive change. And I'll leave it at that. Thank you very much.